Let us wait for 2 minutes for the others to join. Okay, am I audible? I'll share my screen. Am I audible? Am I audible or not?
Yes, ma'am.
Hmm. Okay, thank you. Hmm. Hello. Hello. Okay, I think I am audible now. I was unable to unmute myself. So today the next material which we are going to talk about is your ceramics. Okay. So here you can see what are your ceramics. These are different materials. Okay. Like the ceramics are the clay products. Okay, which we use for some different works. Like you can see ceramics. The pots which we make or the slabs also clay type of roof structure roof slabs also you can make above your uh, houses as some type houses. Okay, the so those are what your ceramics. Okay, you can see here the word ceramic is of Greek origin, meaning potter's art or designs. In the present day, what is happening? Ceramic is used to defeat wide range of silicates, metallic oxides, and other combinations. Clay products are the most common and appropriate example of ceramic materials. Yes, the clay products. Okay, so the general properties of these ceramics are what? Wait, I'll show you. I think what is ceramics. Okay, I'll show you later. So, what is this? The general properties of these ceramics, which is also used for some kind of construction works in your roofs. Also, you can use this clay type of material or as a slab or on the floors outside your house. Those also you can use. Okay, and also for different purposes, the ceramics are used. So the next coming to the general properties of these ceramics, they are very hard and brittle and amorphous. Okay, and also can be glossy. They are bonded by ionic and covalent bond. Okay, this is not covalent, this is covalent bond. As a result, at this bond, there are no free electrons in the structure, which makes them thermal and electrical insulators. Obviously, you know that clay is a very good thermal and electrical insulator. At a low temperature, they deform elastically, whereas the same material may undergo viscous flow at some other stress condition. Okay, so these are the different classifications of ceramics. See, we were talking about the different materials we used in this civil engineering. So we'll just go in short. okay, on all the materials, because otherwise we are taking too much time for one material only. So we'll go in short for all the materials because we have more units to cover. Okay, so these are your different classifications with the, it can be of three types. Your ceramics can be of three types. These are clay, it can be clay products, it can be refractories, or it can be glasses. Okay, so what are your clay products? The ceramics can be, according to their internal structure, it can be clay products. First one, the clay products. Clay with right amount of water possesses high degree of plasticity. You know, when we mix the clay with water, you have a plasticity on that clay so that you can deform them and make different shapes, give them different shapes. Okay, so these clays, because of their plasticity, so these clays can be molded into any shape. Yes, so these molds, when dried and burned, possesses good strength. Okay, this thing, when you give them a shape, mixing with water, your clay, these unmold them and then give, burn them or dry them, they'll give a good strength, and that can be used on your roofs also. I'll show you with some pictures. So the major forms in which clay products are used, these are the major forms. Okay, these can be tiles. I showed you the clay products. Na? I'll show you what is that. And for that, I have to go. Where is, okay? Let's go on. Okay, clay tiles. If I show, hmm. So where I was. Okay, I'll again share my content. Hmm. So you see the clay tiles. If I show you, these are some of the uh, clay ceramics which you can use above your roofs. Okay, these are the pictures. Now I think you can relate with the help of this clay. This can be made. Okay, so these are your clay tiles. It can be clay tiles. Obviously, bricks are also made up of that. Clay bricks are also there because they are made up of soil. When you mix them with water and then again you burn them, you dry them. So these are your clay bricks. Then we have porcelains, your different types of your ceramics, the major form in which your clay product, these clay products, which is also known as ceramic. Okay, this is a part of the ceramic. So these clay products can also be your porcelain. So what is your porcelain? This is actually a ceramic. These porcelains are also a ceramic material, obviously, which are made of heating, by heating. Okay, these materials like porcelains are made by heating, and also they will have a material called as kaolin. Okay, at very high temperatures between 1200 to 1200 to I think like 1400 temperature. Okay, so if porcelain, this, wait, I'll, where is this porcelain? If I show you, hmm, it's not working. So porcelain is this kind where this is same like the clay materials. Okay, you have the clay materials, but you have a material mixed additionally, which is your kaolin. Okay, then you form this kind of, I think my network is poor or what, it's not coming. Okay, so this kind of materials, these kind, here in the picture it is showing like this porcelain pots are made, etc. But with the help of these similar thing, you can make in inside your homes also. Some in the walls also you can give the outer surface, at the outer surface, or the matlab the layer, the outer layer of inside wall, or okay, uh, for decorative purposes. You can give not only making of these pots with the porcelain can be used in your walls also for some decorative purposes, or for some hanger kind of things also for your inside house. Okay, so next is your, this next form is your terracotta. Terracotta is what? This is actually same thing with clay. Different. These are different. These things are different forms of your. These are your different forms of clay. No, that is your. This all are made up of clay. So terracotta is also made of clay, but it is of baked art. Okay, you can say these terracotta is made of baked art, where there are some statues when you make, there is some statues where you will have no finishing is not given there. Okay, glazing is not there. There are some stuffs. I'll show you. Wait. Actually, these are the type of earthenworks which is a clay based. This can be glazed, unglazed. Okay, and their body can also be fired to porous or something like that. Where is this? This one. So if I show you, see, terracotta. These are your made up of these kind of forms. These forms, you can say, these forms of clay are known as your terracotta. You see, terracotta means actually what? The clay form. So this is ceramic, but clay form where you see no glazing is there. Only directly the clay is used, but there is no outer uh, glaze which you was just now I showed you. Just now I showed you in the porcelain, but here you see these. Suppose I'm talking about this pot, then you see there is no glazing outside, only the simple clay portion is there. These also are the statues which are simple clay form. There is no outside glazing kind of material is not outside outer layer. This is simply um, form of clay which is given a different shape, sizes. This also, these are just the forms I'm showing you, but these can be used for your houses also, in your houses also. Okay. Hmm? So these you can also use in your roofs, then in your pipes, water pipes, roofing tiles, or you can say bricks, and just to in your building construction, the surface for if you say for surface embellishments also you can use your this kind of for in this form, your ceramic in this form. Okay, where you don't have the glazing, but simply directly these, you see these are also without glazing kind of material. Like in porcelain, what was happened? There was a kaolin material mixed, and then their surface was so smooth, and their surface was glazing. So that is, this is different in that way. Okay, so this was your terracotta. Next form, if we talk about, is your earthenware. This one, earthenware. Okay, this also since you have to obviously fire or burn these materials, you have to fire and burn the clay, then only you get these forms. So these also can be burned in 1200 to like that, above 1200 degrees Celsius. Okay, this can earthenwares means actually same thing. They can be, these can make your terracottas also. With these are also terracottas. This can be your terracottas. Your also can be absorbed. This can be used for absorbing waters. Okay, this can also be made impervious. Like using some different kind of materials in these earthenwares, we can make them impervious to liquids, giving them a coating. Okay, by using some suppose ceramic glazes, you can say. So these are different. Then stonewares are also there. Same thing with the help of stone wares. What you can do, this clays can be formed in your stone kind of things where you can use as a terracotta. Okay, these were your different forms. So what is your refractories? Next is your refractories. This one, the three types we were talking about, the ceramics. So first one was your clay products from ceramics. Then we have the refractories. What are your refractories? You can see the refractory, it is actually what is a you can say it is a material. These refractories is a metal that will be resistant to decomposition of heat. By this cannot be, this kind of materials, the refractory materials, they cannot get decomposed by heat or pressure or any chemical attacks. Okay, and these can, but still they can retain their strength and form at high temperatures. Okay, like you can see here, a refractory material is one that can retain its strength at high temperature. They can be used as linings for furnaces. So what is the use of this refractory? Since I told you that these refractory materials, what are they? They are resistant to decomposition by heat. You can, because since they cannot be defected by at a very high temperatures or pressures or any chemical attacks. So these materials, these refractories, can be used in your furnaces, because in furnaces we burn things, we at a very very high temperatures. Those structural members are, those structures are under very high temperatures, so we can use refractory kind of materials which can withstand too much heat, as well as they have a very high strength and very high temperature. They do not get affected by chemical attacks also. Okay, so your these refractories are used in your furnace, kilns, incinerators and reactors. Why? Because here in these kind of things we use too much of heat to produce something, and these are your refractories, that are metals which can withstand that much of heat. Okay, so the oxides of aluminium, silicon, and magnesium are the most important materials used in the manufacturing of refractories. So these refractories, they are used in those furnaces, kilns, okay, where we create different materials at a very high temperature. So these can be used. But how you make these refractory materials? These have aluminium, silicon, oxides of aluminium, silicon, and magnesium in manufacturing your these material, refractory material. Okay, so this was one of your ceramic, one type of ceramic. Again, the next type of ceramic was your glass. So this is another ceramic, which is, it is not simple compound but a combination of several compounds. A glass is made up of different type of compounds, you can see. That's why it shines. Okay, when you see the glasses break or broken glasses, you will see that. Okay, so these are, because why? Because they are made up of different compounds, different combinations of compounds. It is a mixture of a number of metallic silicates. Okay, it is amorphous, transparent, and translucent. These are the properties. So these are your whatever I was telling. Yeah, this is your amorphous, transparent, or translucent. It can be defined as solidified, supercooled solution of various metallic silicates having infinite viscosity. Okay, these is what glasses are cooled after heating, when melting and then mixing with different materials. They are cooled at a very they are superly cooled. Okay, for various metallic silicates. Okay, supercooled solution of various metallic silicates. Okay, so having infinite viscosity. Obviously, when you are glasses, when you heat the glass, it be in a viscous form. Okay, now these are the different steps for your manufacturing of glass. We'll not go in details, but so manufacturing process of glass essentially consists of these things: collection of the raw material, then mixing them. Okay, for the different products of your glass to form different glass products. Then we melt them. When we collect the raw material, then we mix them. Suppose you want to mix this compounds together, and then form different bottles or different glasses for your windows, etc. Or not only for windows, for any other, for doors also some of them uses glasses. So these kind of those are nothing but ceramics. Okay, this can be formed by collecting the raw material first, then mixing, then melting those mixed materials, different materials together, and then we fabricate them, and we anneal them. That means we give the different shape and sizes, whichever we want, designs, whatever we do, the decorative things, and then we then these glasses are exported. Okay, so this
All the
was
glasses are made of metallic silicate.
yeah, there can be different forms, okay, for these glasses, but we're not going details. I'll show you, I can show you one videos on the manufacturing of this glass, but not in theoretically, I'll not show, okay, because too many materials are there to discuss. So in short, I have just given you these things, okay.
So we can use different materials for different glasses.
Yeah,
Okay.
but mainly you will have to have these metallic silicates, okay. There are different metallic silicates, okay. It is not like that only one metallic silicates is there, okay. Actually the most familiar one, if you see, for glasses, if we talk about the glasses, it is non-crystalline, yes or no. So often we this is very much transparent and amorphous, okay. So for rapid cooling, when we use, there is also on the temperature also, it depends like what kind of you want. Some glasses, there can be volcanic glasses also, which are naturally occurring, okay, but we don't use generally for our construction purposes, we don't use that. We get the product from the naturally from the volcanic glass, but we have to uh, convert it so that it can be usable. We can manufacture those, because see sometimes what happens, there are so many glass products. Suppose you have broken some glasses, your windows are broken, or any kind of glass materials are broken, we throw them, and then what happens to those? They are recycled. And how they are recycled? By mixing different materials. So suppose from different sides, the glasses from different sides, different glasses, different types of glasses are collected, and then they are batched mold, they are mixed together, then they are melted together, and they will form different material, different glass, okay. Actually they are all silicate glasses only in the oldest type and history, in the oldest form, if you say, they are all silicate glasses, okay.
Nowadays,
Based on
ma'am,
their
we have
chemical compound, silicon
now.
dioxide will be there, okay.
Okay, okay. Nowadays, we are seeing that most there are different, price of the glasses. What things that
Yeah,
make
yeah, for that only.
difference in the
Depending upon the
price?
the amount of material which you're using inside, because some of them are primary constituent, so it is sand is also there. With the help of sand also you mix there. But nowadays some soda lime glass is also there, where you will find like 70%, you can say, for 70 to 75% silica will be there. Okay, so most important is a silica, but after that what you use, whether it is you can say whether it is simply a recycled one, you have mixed and you don't know the different compounds, okay, based on that your quality will depend. If you use more amount of silicon dioxide, or if your silica is less, okay, then your glass may not be of a good quality, and based on that your price will also depend, okay. Hello. So this was your glass. Now if I show you another one, the different next, if I wait, let me search where is my sixth. This is sixth to seventh one. Hmm. Now your this is next material which we'll be talking about is your bituminous materials. Okay, next we are talking about your bituminous material, where you will have now what you know about bitumen materials that are bound together with bitumen are called bituminous material. Okay, you all know already what is bitumen because they are byproduct of petroleum. So the use of bituminous material was initially limited to road construction. Now the application has spread over the area of roof constructions for industrial purpose, carpet tiles, paints, and as special coating for waterproofing. Okay, so what is the main difference between your bitumen and tar? If you say when compared to tar, bitumen is less temperature susceptible. Okay, so for a given temperature, the bitumen has larger stiffness compared to tar. So now tar is not used, that's why we use bitumen or asphalt. So these proved higher deformation resistance and softening resistance compared to the tar. So since they are your bitumen is less susceptible to this temperature, so these are higher, these provide higher deformation resistance and softening resistance as compared to your tar. Okay, so in future under high abrasion forces they behave more brittle and highly crack resistance. Now we have with time the vehicles increase, so the traffic, hence it was essential to bring, yeah, why we needed this thing, it is just told here that because of the high traffic flow obviously the road strength has to be increased, so therefore we used to do the bitumen before we them in the
Ma'am,
ancient times. Yeah,
are you showing some slide?
no PDF.
Oh, no, no, we can see nothing.
Huh?
We can see nothing. Blank. Your name is there.
Okay, okay, wait, I think yes, I thought I'm sharing my screen. This one now it is visible. Now it is
Yes, ma'am.
visible. Yeah,
No
these
for
are,
me. No
yeah.
for me.
Huh? But I have shared my screen, and now we have
Oh, it's
left
yeah.
with,
No, no.
yeah. But now we have left with 5 minutes, so I'll share the link. Let me share the link for attendance. You people give the attendance with the help of the link. Let me share it. Material testing. Attendance. Just go to the link and give your attendance. I've shared in the chat box the link for your attendance. You can go and check. $69.
Can you share the PPT of the last classes?
Sure. Till
Like
where I have shared the last PPT.
first one, introduction story. Yes, we need second one.
No, the last topic you tell me which I shared with you. Just check the PDF which I shared. Next class we will be doing about types of vitamin.
Readily mixed concrete, ma'am. Till you have shared readily mixed concrete. Readily mixed concrete.
Okay. I'll share after that whatever we have gone through in class. I'll share that in PDF. Okay, you have given your attendance. Let me ask something. Okay, I'm trying something. Information breakout. Assign. I'm not able to.